Alright, here's the first part of the review. Just go down the questions one at a time. Obviously starting with number 1. So we're looking at, well, there's 4 numbers here. There's no letters. So we're simplifying, meaning we're going to step by step make it a little smaller each time. We do that by following order of operations. So PEMDAS. And so we're going to look inside the parentheses first. Right here, there's only the 1 number, so we can't really do anything. But inside the second parentheses, we've got 2 things going on. We've got subtraction as well as an exponent. So, of course, exponents come before subtraction at the very end. So we're going to just look just at these exponents here. That's a pretty straightforward one. 2 squared, it's just 2 times itself, gives us 4. And then once we've done that, then we can go ahead and put the negative in front of there. We're subtracting 4. Put the parentheses around it, keep that there, and I'll just go ahead and write the whole rest of it just the way it is. And now we basically have 2 operations going on between the 3 numbers. We've got subtraction right here, and we've got multiplication right here. Again, multiplication comes before subtraction, so we can go ahead and multiply these 2 negative numbers. 5 times 4 is 20, and then a negative times a negative is a positive. I'm still going to copy down all of this. Didn't do anything with it, and we're down to 2 numbers with 1 operation, subtraction. And number lines are going to come in handy later on down here. But if we think of any kind of combining, this is not multiplying, since there's subtraction in between, and that subtraction might not be helpful, but what is helpful is thinking of it on a number line. We have 0 on the number line here, and if we go 10, 20 to the left, we're at negative 20. So we've gone to negative 20. That's the first one. And then we go to negative 20 again. So we go another negative 20. And that takes us to negative 40. So when they have the same sign, in this case we went left 2 times. So we added those together and we got negative 40. Obviously, if they had the same signs, 20 plus 20, we would have gone right 2 times and we added them. If they have different signs, if one of them would have been actually positive, then we use subtraction. So there's the answer to problem number 1, and we'll go ahead and take a look at the second problem on here. So now we get into some algebra. We've got a variable in there. We need to solve for that variable. So basically, we need to get it by itself. We're going to isolate the variable. And we do that using opposite operations. And so we also have to do the opposite order of operations. Normally we do what's in the parentheses first, but we're going to save that for last. So we can take a look at this 1/4 out here. If you guys don't like working with fractions, you can treat that fraction not as a fraction, but as a division problem. 1 divided by 4, which will give you 0.25. Makes sense. 1/4 is 0.25. I'm going to write the rest of it just the way it is. Our variable k minus 1 being equal to 7. So now we see some multiplication going on right there between the 0.25 and the 2 terms inside the parentheses. We could distribute this. Well, yeah, maybe I'll go ahead and do this 2 different ways. So whenever we see parentheses like that, we can't do what's inside. We can distribute it. So 0.25 times k would give us 0.25k. And then 0.25 times negative 1 is obviously negative 0.25. 0.25. Now that's equal to 7. And we've got two things keeping the y from, or the k from being by itself. And so we need to get rid of the 0.25 that's being multiplied, as well as the 0.25 that's being subtracted. Remember that we have to get rid of the things that are furthest away first, so we do the subtraction, and that's also opposite order operation, subtraction before multiplication. The opposite of subtraction is addition. I'm going to put plus 0.25. Anything we do to one side, go to the other side of the equal sign and do the same thing, plus 0.25. So now it's gone over here, and we have 0.25k is equal to 7 plus 0.25, which is 7.25. Now we need to get rid of this 0.25 that's being multiplied by k. We undo multiplication using division, so I'm going to put a division bar underneath that and divide it by what k is being multiplied by. Anything divided by itself gives us 1, and 1 times k is just k. So that's how it gets it by itself using division. I'll make sure to keep it equal. Divide the other side by 0.25. Normally when we divide we get a smaller number, but since we're dividing by a number less than 1, we actually end up with a larger number. 7.25 divided by 0.25 gives us 29. Alternatively, we could have taken our almost original equation, just having changed the fraction to decimal, k.1 equals 7, k minus 1 equals, sorry, and we can do the division right off the bat. We see it's being multiplied like I mentioned, and rather than distribute, we can undo that multiplication using division, dividing both sides by 0.25. These cancel out. We're left with k minus 1. And if you take 7 divided by 0.25, that gives you 28, which should make sense over here. We had just a little bit more divided by 0.25, and it gave us 29. So the last step is to get rid of that negative 1. Opposite of a negative is a positive, so if I have negative 1 and I add 1, they cancel out. We could write k plus 0 is equal to 28. Plus 0 is a waste of lead. Keep it equal, add 1 to the other side, we're left with k equals 28 plus 1, which is 29. So there are two different ways, if you're more comfortable with distributing, to do that first. So you get rid of the parentheses, you can do that. Otherwise, we do what's furthest away from the k first. We cancel out that 0.25 first. All right, that one was a little bit harder. This one, I think you'll find, is going to be more straightforward. So again, we need to get the w by itself. Problem is, we have two terms with w's in them, and so we need to get rid of one of them. I always tell you guys, or have told you guys, to get rid of the smaller one. That'll leave us with a positive number. So I'm going to take a look at this w over here, and I'm going to do the opposite of a positive w. I'm going to take away w. That should be pretty straightforward, that if you have something and you take away the exact thing, you're left with nothing. Look at the other side of the equal sign. So always identify where that equal sign is and go to the other side of it. We find a like term. I could take away w here, but that doesn't really do anything since 2 and w are not like terms. But since this other term has a w in it as well, they are like terms. So I'm going to put minus w underneath. We can think of this as negative 1w. And if we have 3 minus 1, then we have 2. And we'll go ahead and keep the w behind that too. The rest of it, these two things, I'm going to copy down. Those didn't change, so we have a plus 2. On the other side of the equal sign, we just have a minus 4. So now we're down to a two-step equation, just like the last two steps of the previous problem. We want to get rid of the number furthest away from the variable first. Also, we're doing opposite order operations, so we're going to do addition or subtraction first. This is being added, so we're going to use subtraction, get rid of it. 2 minus 2 results in nothing. Keep it equal, take away 2 from the other side, and we'll go ahead and rewrite it. 2w is equal to, and be careful on this one, negative 4 minus 2, they have the same sign, so we're going to add them and make our answer negative. If we owe somebody $4 and then we take out another loan, or they let us borrow another $2, then we have a combined debt of negative 6. We owe $6. Very last step is oftentimes division. We see multiplication here. We're going to undo that multiplication using division, divide exactly what the variable is being multiplied by, keep it equal, do the same thing to the other side, and now we're left with w being equal to whatever negative 6 cut in half is. Negative 6 divided by 2 is just negative 3. And basically we had 3 steps there. Our first step was to get so we only have one w. Our second step was to get rid of the addition, and our third step, get rid of the multiplication. We got our variable isolated, across from it is our answer. All right, so we're going from solving equations to working with inequalities. And we need to write an inequality that represents all of these solutions right here. So the first thing we're going to do is start with a variable, and x, probably the most common one you use, and it's going to be, we're going to change this middle part, but for now we're just going to say x is equal to some number. So there's a point on this graph, that's the point we're looking at. In this case it's 1.5 or 1.5. And so now we just have to make this the right sign here. We have 4 different options. So I'm going to go ahead and get rid of that right there. So our options are either we can say x is greater than the number, x is greater than and equal to, with a half equal sign underneath. We say x is less than, or x is less than and equal to. We have to decide which one of those go in there. So compared to point 1, looks like x is greater than. So we want to choose the one of these where the alligator mouth is facing towards the x and wants to eat the bigger thing. So both of these are what we're looking at. And then the very last thing is to look at that point itself. If it's colored in, that means it's equal to 1.5. If it's open, that means 1.5 is not a solution. Here it's open, and so open looks like that sign. It's got the half equal sign. We know we're going to have a closed dot. So we have an open dot. Let's just fill this in right here. And no math involved. It's just a matter of picking out that starting point, and then choosing the correct alligator mouth inequality sign. All right, go ahead and look at the fifth problem, and we're basically just doing what we did there in reverse. We're taking some from the problem 3 as well. So in order to make it look like our solution to problem number 4, we need to get the variable by itself. So we do exactly what we did in problem number 3, and we could take away 5 from both sides, 5w that is. We would end up with 0 over here. We would only have one term with a w, so that'd be good, but that term would be a negative. and it would have a lot more to, it would have negative 11 as well as a positive 11 to get rid of it. So this is why it's just going to be easier to get rid of the smaller one, negative 6. Any negative number is smaller than a positive. So I'm going to get rid of that. Opposite of negative 6 is a positive 6. Keep the W behind it. And this time we're looking towards the other side of the inequality. So find our inequality sign and put a plus 6W over there. Negatives and positives cancel, and 5W's plus 6W's gives us 11W's. Keep our inequality sign, and then all we have left over here is plus 11. I don't need to write the plus, I can just write 11. Again, the very last step, we see multiplication, we undo it using division. So I'm going to put division bars under both of these, and then I'm going to divide by 11. So before we would have ended up doing some dividing by negative numbers, and so whenever you divide by a negative number, remember you always have to flip the direction of your inequality sign. So if it would look like this, we need to change it so it looked like that. That is only if you're dividing or multiplying by a negative number. For your last step, we are not, so we're not going to have to worry about it. Anything divided by itself is 1. 1 times our variable is just our variable. And so we're left with just W. And then inequality sign. And then, again, something divided by itself is 1. So here is our inequality. So we did that part. We solved the inequality. Turns out W is greater than or equal to 1. And we need to graph it. And by graph it, since we only have one variable, we don't need an x and a y-axis. We call this a w-axis, but it's just basically a number line, like in problem number 4. We find where 1 is on there. I'm going to put a 0, and so we can put 1 right here. You don't have to put any other numbers. If you want to, you can. But we're going to put a point at 1, because that's the number mentioned in our inequality statement. And from the last problem, remember that when we have that half and equal sign underneath, we're going to color it in. Our solutions include 1. 1 is greater than as well as equal to. So our variable being greater than 1, we want to shade in everything greater than 1. So the main thing on this one was if you're multiplying or dividing by a negative number, make sure that you flip the direction. I think this is not necessary, so you're welcome to skip to the next problem, fast forward. But I will show you that if we were to do it the way I originally said, where we get rid of the 5W, so we would end up with 0 on this side, and we would have ended up with a negative 11W over here and a plus 11. Really quickly, take away 11 from both sides. We end up with minus 11 being greater than or equal to negative 11W, and this is a case where we have to divide by a negative number. Do that to both sides, and we end up with negative divided by negative over here, which is just 1. And then for now, I'm just going to copy that inequality sign just the way it is. These cancel out, and we're left with just W. As you can see, these two solutions are almost the same, but not quite. This one is saying 1 is greater than W, therefore W would be less. This one is saying W is greater than 1. So that's just showing that when we had the negative number that we were working with in front of the W, that we had to remember to change the direction of these signs. So it's always easier, and that's not the only reason why it's always easier, but generally it's easier if you can not work with negative numbers. It makes less room for error. So all that on the side, we just kind of explain, show why when we divide by a negative, we have to change the direction of the inequality. And if we can do so, just avoid working with negatives by getting rid of the smaller, the term with the smaller number. So last problem on this side, and what's our time sitting at? 20 minutes. Yeah, I'm going to call it end of the video after this problem. So identify the independent and dependent variables in the table below. So that's our first instructions. And to do this, we kind of think of things that the one would affect the other. And so we have the speed of sound in air. And so sound travels at different speeds in different air temperatures. And so we think to ourselves, would the speed of sound cause the temperature to change, or would the temperature of the air cause the speed to change? And so the first one hopefully sounds a little bit crazy. Like if sound is going through air at a certain speed, and if it speeds up, it's going to make things like the air temperature hotter. That is not very likely. The best explanation is the opposite of that. That depending on the temperature of the air, sound will travel faster or slower. So temperature is independent. It does what it wants. It's not going to be affected by the speed of sound. So we're going to call temperature our independent and the speed of sound is going to depend on the air temperature. In a second here, we'll make a graph out of those, but first let's just see what's going on that changes between each one of these. The temperature is pretty clear to see that every time there's a new number on here, it goes up by 5 degrees. From 15 to 20 is 5, 20 to 25 is 5. So it goes up 5 degrees each time. Let's go ahead and see the velocity, how much the speed changes. So 37 to 40, we can just subtract those. So if you have 40 and you take away 37, hope we can see the difference between those is 3. This one's even easier. The difference between 43 and 40, again, looks like 3. So it looks like 3, two of these 5s here. It changes by 3. And so we're going to use this to find our slope, but we need to go back and find our y-intercept. So imagine if we went back to 5 and then to 0. Down here, we would change by 3 each time. So this is kind of hard to see. I'm looking at this 0 right here, and I have to use this funny looking pen, otherwise my screen breaks. So I'm going to take away 3 each time. If I have 337 and I take away 3, I'm going to be left with 334. And finally, take away the 3 from that, and I'm left with 331. So let's write the equation first. Or actually, the words, in words. Describing this using words. We're going to use words first. And it's pretty straightforward. We see that every time temperature rises 5 degrees, velocity increases by 3, I guess they're measuring it in meters per second. Every time temperature rises 5 degrees, velocity increases by 3 meters per second. We're going to put that into an equation. It's going to be y equals mx plus b. So I'm going to say y equals mx plus b, and the slope is going to be the rise is going to be our velocity. So I'm going to put a 3 there, and then the run is going to be our temperature. So I'm going to put a 5 there. And then the reason why we went back and found our 0 is so we could find our y-intercept, and when our temperature was 0, our y-intercept is 331, so I'm going to put a 331 here. And finally, to graph this, important that we put the independent variable at the bottom, so we have temperature for our x-axis and speed for our y-axis, and we can imagine being all the way up here. We can say that is 331. So when temperature is 0, our speed is 331, and then every time our speed increases by 3, so from 331, we go up to 334, and we go, our temperature increases by 5 degrees, so we go over 5, up 3, over 1, 2, 3, 4, 5. And every time we went up 3, 1, 2, 3, we'd go over 1, 2, 3, 4, 5. You could do that as many times as you'd like. 3 is plenty. And so now we have a graph, as well as an equation, and in words what our original table was showing. Alright, call it good for the front side. I'll start a new video for the back side.